So this video is just going to give us a quick introduction to all the terms that we need to know when we're talking about polynomials in class. So first thing we need to be able to define is what the heck a polynomial is. This definition is straight out of the textbook that my course happens to be using. A polynomial is a variable expression in which the terms are monomials. This is a particularly gross sentence to unpack. It is one of the less friendly definitions of polynomial I've seen. But every definition of a polynomial requires us to have this definition of a monomial first. So I'm actually going to take a step back and we're going to talk about a monomial. So a monomial is a number, variable, or product of numbers and variables. So what does this really mean? Well, the most important piece of this is the word product. Product here is telling us that we need multiplication, right? Without multiplication, we don't have a monomial. So we are not allowed to have other things in there like addition or subtraction. Division can be problematic, but division within the number portion is fine. So some examples, a very traditional monomial might look something like this, 3x. We have 3 and x multiplied together, right? So they're a product. We can just also have straight numbers. So 1/7 is an instance where we also have division, but this division is okay because our division is happening in the number portion, and numbers can include fractions, decimals, negatives, all those good things. We could have variables by themselves, obviously. And we can also have things like 14x to the 7. This still fits into this definition of a monomial, even though it has an exponent, because an exponent at the heart represents, right, this is 14, and we can actually expand that exponent as multiplication. So this is a product of numbers and variables here if we actually write it out as a product. So an exponent is just shorthand for a product, so it's completely allowed. Some things that are not allowed or not okay. Some examples would be like 1/3x, because now our variable is it's in division, right? We can almost rethink of this as 1/3 times 1/x. This is not allowed. So we cannot do that. What else can't we do? Well, we can't have square roots. We can't have anything else fancy. We can't do something like x plus 3 because we have addition going on, and that's a problem. So monomials will look something like we have here. We can make these as complicated as we want. Still, we've got a number times variables, right? That's completely okay as well. So that's what we're looking at in terms of our monomials. Now let's unpack the terrible definition of a polynomial from our book. It is mathematically correct. It's just mean for those of us who are not math people. Terms means things separated by addition. That's what terms means. This is useful because we do get another definition that is actually terms of a polynomial, and we've gotten it within here. But you can also just think of a polynomial as either being a monomial, so a different definition would be a monomial, or the sum of monomials. So that's another completely fine definition for a polynomial. That's a little less mathy and hard to unpack. The last thing you might need to unpack in this sentence is this whole idea of a variable expression, which just means it's an expression that includes operations like addition, subtraction, multiplication, and division. We don't have an equal sign though. That's the big difference between an expression and an equation. So that's a polynomial. Just to give us a quick example to be using throughout, here's a lovely polynomial. Let's do -3xy plus 7y to the 14th minus 1/5 x to the, I don't know, let's leave it x plus 12. So this would be a polynomial. We have a bunch of things here separated by addition. You may not see the physical addition here, especially with the ones that have subtraction, but just remember that we can think of any subtraction, as adding a negative number. So if we wanted to, we could actually unpack this and stop saying the word unpack so often, but we could actually break this down into the different terms that were available. And this is something I've had my students do before on tests, is that we can sit there and go, okay, break this down, write down the terms of the polynomial. And we're going to keep doing stuff with this table as we go. We're going to get a couple more definitions. So the first term, the first thing separated by an addition symbol, is that negative 3xy. The next thing between addition symbols is that 7y to the 14th power. The next one, we know that we can add a little invisible plus there. That negative does stay with the term, negative 1/5 x. And lastly, we have that positive 12 by itself, right? 12. So those are our terms. Now, within the terms, we do have two other definitions that might come up that we should probably know so we can talk about polynomials. The first one is the degree of a term. The degree of the term is literally the number of variable factors. Factors just means things that we are multiplying together. So how many variables are we multiplying together in this term? So for the first one, if we were to go ahead and define these things, so let's put our degree up here at the top. The first one of our terms here has two variables multiplied together, right? We've got 1 and 2. So degree, 2. The next variable, if we expanded this, there are going to be 14 y's all multiplied together, so 14. Usually if we just have for only one variable, the degree is just equal to the exponent on the variable term. That's it. If you have two variables, well, you'd have to add the two exponents together. So in this case, 1 plus 1 gives you 2. And that's sort of a shortcut. If there's only one variable, you can still think of that exponent as being 1, so you have degree 1. And if there are no variables, well, how do we write none of something in math? We write a 0. You could also think of this, if you wanted to be a little more mathy about it, as x raised to the 0 power. Because if you remember your exponent rules, anything raised to the 0 power is just 1. But if you have this definition here at the top, the number of variable factors, it makes it even more obvious why your degree is 0. The other definition that we need for this is coefficient. It's a word I use often as I teach. Coefficient is just the number portion or factor of the term. So all you're doing is pulling off the number portion of each of these. So coefficient, we have -3, 7, -1/5, and 12. That's it. If you have to fill out one of these tables, it's just picking apart what the different parts are. The next thing you need to be able to do with your polynomial is to define the degree of the polynomial. So each term has a degree, but the polynomial has a degree as well. The way you get the degree of a polynomial is you just grab the largest degree term. So this is the largest degree of any one. That's one. That's terrible handwriting term. So the largest degree of any one term. So the degree of a polynomial for this example would just be 14. This is important. This degree and coefficient becomes really important if you're going into pre-calculus, because just glancing at the degree and the coefficient of this tells me what this graph is going to look like as x gets really large or really small. Specifically, this one is going to, go towards infinity on both directions. So I can already see that there's going to be some sort of range restriction going on with this polynomial, because this biggest term, what we would call the leading term, if this were a single variable, really tells us everything there is to know about it. Now, this is much more complicated because it has x and y's, but that's how we end up using it in pre-calculus. So degree of a polynomial, factors. Oh, the only other thing we need to define, if we want to really make sure we know every single definition that can really come up here, with our polynomial is we do have two other special cases. A monomial is a special case of a polynomial, right? It's a polynomial with one term, but a monomial is still a polynomial. A binomial has two terms, and a trinomial has three terms. Especially when we start moving into factoring, we may be using this language a lot more in terms of, oh, it's a trinomial, so this is the method we use. Or, oh, it's a binomial, so we're going to look at difference of squares or whatever it might be. And just to give us some examples to finish this up, a monomial would look something like that. Binomial, now you're going to have two terms. And a trinomial, you're going to have three terms. And you'll notice how I made sure to keep these so that you couldn't actually combine like terms. And the only other thing you might want to know about polynomials in terms of definitions, whoa, that is so not how you spell descending, is descending order. Descending order just means that you write the parts of your polynomial so that the degrees get smaller as they go. This is, again, just to make life easier on you when you get into like a rational, when you get into graphing in pre-calculus, is to be able to look at this and say, okay, I know everything about this graph, because it really doesn't matter what happens after that leading term, which is what we call this. So that's everything you need to know in terms of definitions about polynomials. We'll continue on in the next video looking at addition and subtraction of polynomials.